Well, ozone has resonance, and the reason we knew is because when we draw its Lewis dot structure, we had to choose where to put the double bond, and that tells us that those two possibilities are equivalent, and what's really happening is that those electrons that made the second bond are actually being shared across all atoms. So anyway, that's your clue for how you know that you have resonance, is that you have to decide which place to make the double bond. That's just your clue for, that it is happening. It's not really representing what is happening. It's not like the double bond is here and then there. It's just your way of knowing. So if you have to choose where to put it, it means that you have resonance. Resonance is caused by delocalized bonding. And just so we're clear, delocalized bonding is another way of saying that something has resonance. What's really happening is that you have electrons that are being shared by more than two atoms, so they're delocalized over the molecule. They're not stuck between two atoms. Whenever you have delocalized bonding, you're going to draw all the possibilities with the arrows in between, like we did for the O3. And again, the true molecule is a blend of all the ones that you draw. It's just the way we draw them. Let's try another one. So nitrogen is different. We'll put it in the middle. And then we'll put the oxygens around the sides. Different in the middle, around the sides. Let's count our valence electrons. Nitrogen has 5. Oxygen has 6. So that's 18, that's 23, but then don't forget that this negative charge means that you have an extra one. So that will give us 24 valence electrons. Okay. When we go to put them on, we always start with the outside atoms. Make sure they have their octets first. Oxygen does need 8. Okay, and I got those all on. Let's count. How many have I put on already? And you can kind of see it's like 8, 8, 8. Remember the double, the bond counts as 2. So I already have 24 on there. And the problem is if I look at nitrogen, nitrogen right now only has 6. So I need to do my trick, move in a lone pair and make a double bond. And I could do that with any of these oxygens. So I'm going to do that for each one. I'm going to show all of the possibilities. Okay, those are all the possibilities. And so I've drawn my resonance structures. I need to put arrows between these to show that they are resonance structures. And I need one more thing on this one. I need to make sure I put brackets. Anytime you have a polyatomic ion, you need to put brackets. You could put them around each one of these, but I don't mind if you just, because it gets kind of messy, if you want to just do the whole thing. And it's a -1. By the way, we have been leaving space over here on the right because we're going to come back and do the structures later after we look at the geometries. Let's try one more. And on this one I gave you a hint. Avoid making a triple bond. And that's always true. If you can draw a structure without a double bond, then draw it without the double bond, unless you know something experimentally from a structure. Same thing with a triple bond. But anyway, so let's just go through the steps. I start with my skeleton, count my electrons, 4 for carbon, 6 for the oxygen. So I've got 16 valence electrons. I'm going to start by putting them on the outside atoms. I'm going to count after the outside atoms have their 8. I'm going to count, and I have 8 and 8. Oh, 16. I've already used them all. Okay, that would be good, except carbon doesn't have nearly enough. Carbon only has 4. So I'm going to need to move some pairs in. So let's just start here. I'm going to take those and put them there. And then we can see that this carbon, now it has 6. It still doesn't have enough. And now I have a choice to make. I could take another pair from this side and make a triple bond. But this is where the key was. Don't make a triple bond unless you have to. So for my next pair, I'm going to take these and move them there. Okay, so this one does not have resonance, because that's the only way to do it, the only equivalent way to do it. So it has no resonance. Let's go back up here and label something on this one. If I asked you on this one, we would say this has 3 resonance structures.